morning, everyone. We are living in the world of disruption and huge disruption in aerospace and defense. And I wanted to ponder on few thoughts. And since there are a lot of folks from industry and academia, I wanted to give some specific suggestions or my thoughts, share some thoughts, so that we can be the leader in the future of this disruption. So let me start off quoting the chairman of GE, very recently. He said, if you think of GE is an industrial company, if you went to bed thinking that GE is an industrial company, you wake up realizing that GE is a digital company. I think it really captures really what's the disruption that we are talking about. So the digital aspects of the engineering, the manufacturing, the testing, all aspects of the digital and what digital can do is the biggest disruption. And just this week, 3 days ago, there is a big movement of pride. I think it's something that we all must celebrate in the space of aerospace and defense. There is an engine which is the most modern aircraft engine in the history. It's called a LEAP engine, which took the revenue service, the first flight. And what is more important is that not only it is the most modern jet engine, but it has two key things which really talks about this disruption that I would elaborate. The first thing is it has the engine has additive parts, the fuel nozzles and some of the components. They are real engine parts which are made out of additive manufacturing. Right? We still think of additive manufacturing, 3D printing, but here is a case where we have actually put these parts into the hot section of the jet engine. And why we could do it? It's because we have been actually working on this additive technology for last couple of decades. The second thing that it has is something which nobody would ever thought is about the ceramic matrix composites. Ceramics are very, very brittle, but they are also very good for high temperature and high efficiency. And this engine has some very complex parts made out of ceramic matrix composites. It talks about material science. The one talks about the manufacturing. And what we are trying to do through the digital, let me give an example. Today if a jet engine comes to service shop, the engineer in the field, he takes the photographs, he understands, he opens the parts, he says, okay, how good or bad is the engine or the parts, and then the engineering team actually analyzes and says, okay, whether it's safe to fly, because it's highly safety critical. But think about it, the engineers actually from our center have developed an app where you can take, click photographs from your iPhone, and it processes, it exactly knows what's the damage of those turbine blades, and it pulls in all kinds of engineering information. It does the calculations, it throws the number on your cell phone as to how many more cycles it can withstand. Think about it, what digital can actually enable. So this is the kind of disruption that we are talking about. So this is just the beginning. If I think of what are the future technologies and what we need to do as a country and as society, let me share 4 things which I see is going to happen in next 10, 15 years. The first thing is around all the products that you see flying, whether in aerospace and defense, they're going to completely change in next 15, 20 years. Take about the products, the commercial aviation, if you see. I think in 15, 20 years, we see that we would have some kind of hybrid propulsion. It's not just gas turbine switch power, but it will be a combination of electricity and the typical gas turbine propulsion, which will be powering the future of aviation. Now, if you see in the military side, the conventional warfare, the electronic warfare, transitioning into or transforming into digital warfare, and with all kinds of different products. And what is going to drive is products like drones or the combination of the system integration, the engines, the avionics, the airplane, the better integration of all this can give a much better product. So, and not to mention about space tourism, not to mention about flying cars. There are all these products which are actually reality. If you see what's going in the last few months in the aviation space, there are already products which are there based on hybrid propulsion. Right? So it's a reality, and in the next 10, 15 years, we are going to see a huge disruption on the way the products look like. The aircraft will look different, The propulsion systems would be different, the avionics would be different, the electronics would be different. So that's one aspect. The second thing is around uh, the overall digital, right? I gave an example of how digital, the technology can be applied. It can completely change the way we design, manufacture, test, and do engineering and product development. And technologies like additive, even the material science, think of additive, what it can do. I'll give an example here. The many of you, if I ask where Nike manufactures shoes, you would say, maybe China or some other country, right? If you see, Nike is not actually manufacturing some of the high-end shoes in China anymore. They're actually doing it in US. Why? Because you can actually print this. You can even you can ask the customers exactly what type of combination of shoes you want, and you can actually print it and deliver. So think of all the customers who are running these huge cargo planes, people who are into the cargo business, they will be disrupted by additive technology, right? So it's a huge disruption. And when we think of additive, we think of designing. You would have designed a part, and you are only thinking of how to print through additive. But that's not the way, or that's not the true power of additive technology. We need to think of how to design for additive. You don't have to have the constraints from the conventional manufacturing when you think of printing something through additive. And you can think of printing anything. It could be a combination of metals, composites, sensors in it, controls in it, and whatnot. That's the future, and that can disrupt many things that we do around engineering. And the last one, I wanted to leave this thought around the systems thinking. I think if you look at what happened in last particularly 20, 30 years of engineering, it was all about core competency. Every company believed in this concept of core competency. What are you good at? And everybody picked up some things like, maybe making something, at a component level. But what is going to change in the future is around system thinking. It's not about component. It's all about system. And aviation is all about systems of systems, very complex systems. So this mindset of system thinking is a big enabler. How do we think of the entire product from design, engineering, manufacturing, testing? And that whole product mentality is something which is going to change. So when we think of all these products, we need to embed and consider these technological changes. And I wanted to leave two thoughts with the industry and academia, so that you can actually take this forward. First and foremost, what is really limiting us? What's the biggest constraint from our country? I think it's all about mindset. As somebody said, the problem is not about setting, some goals and meeting. It's all about setting higher goals and maybe not meeting. So it's very important for us to set very higher standards and higher aspirations. I think we really lack in that aspect. Think about most of the companies, and I'm not picking any company here, but most of the companies would have this name, technology services, engineering services. When you say that your company is services, the next things wouldn't happen. You are in the mode of servicing somebody. It really limits our imagination and thinking and design and what else we can do in our country. So my first recommendation is please drop out that name called services. At the end, it may be services, but I think you want to inspire your employees, engineers, yourself, and everyone around that it is all about technology development or engineering, not doing services. That's the number one. I think then that will enable us to think of systems, design, manufacturing, all those things. The second thing is, the second thing is around this disruption. So I think we need to really think of what would be the next disruptive technology that we would lead from our country. And there are so many opportunities. And I would only recommend the companies to invest some money around R&D and technology development. It's very hard when when you have to deliver for today, but we need to also invest for tomorrow. So these are the two thoughts. And I think with this, I hope that we would be the country which will really, define the future in the aviation and defense space. Thank you.